I am Dr. W. Gunule from Kamla Nehru Mahavidyalaya, Nagpur. Today we are going to discuss the oxyacids of phosphorus and sulphur. And also we are going to see here the different structures of these oxyacids, and especially we are going to see the Marshal acid and the Caros acid. So today's topic is oxyacids of phosphorus and sulphur, and here we are going to see the structures of different oxyacids of these phosphorus and sulphur. And here in the next slide we are going to see the oxyacids of phosphorus, and here the table is shown, and in this table oxyacids of phosphorus are shown, and in this case the name of the oxyacids of phosphorus are hypophosphorus acid, phosphorus acid, orthophosphoric acid, metaphosphoric acid, hypophosphoric acid, and pyrophosphoric acid. And formula is here: H3PO2, H3PO3, H3PO4. This is HPO3. This is not H3. This is HPO3, H4, P2O6, H4, P2O7. And their oxidation state are shown here. In this case, the phosphorus have +1, +3, +5, 5, +4, +5. And whether they have how many number of OH groups are present in the structure of this compound, depending upon that, they are. This first is a monobasic, dibasic, tribasic, again monobasic, tetrabasic, and tetrabasic. So these are the different oxyacids of phosphorus here shown, and here we are going to see the structures of these compounds. So in the next slide, this is the structure of hypophosphorus acid, and first number is the hypophosphorus acid have the formula H3PO2, and this is monobasic acid, and it has only one ionizable. So in this case, this is the structure, and in this case this is the tetrahedral structure of, because phosphorus have 5 electrons in the valence shell and forms one double bond with the oxygen and 3 with the here in this way 1, 2, 3, and hypophosphorus acid formula is H3PO2. So this is the structure. In this case it contains one OH group, therefore one hydrogen get replaced from this OH group, and therefore there is a replaceable one hydrogen atom, and therefore it is a monobasic acid, and this is also there is only one ionizable hydrogen, and therefore it is monobasic acid, and this is the structure for first H3PO2. Another, now this phosphorus acid have the formula H3PO3, and this compound have similar structure but having two OH group, and presence of two OH group, two replaceable hydrogen atoms are there, and therefore this is a dibasic acid. Third compound is the orthophosphoric acid, formula is H3PO4. So in this case the structure is same, and now here this there are 3 OH group, 1, 2, 3, therefore 3 replaceable hydrogen atoms are there, and therefore the compound is a tribasic acid. And now here all the 3 structures of these oxyacids based on sp3 hybridization of phosphorus atom, and overlap with the 4 sp3 hybrid orbital of phosphorus, each containing 1 electron with suitable orbital of hydrogen and oxygen, give 4 sigma bond. The 5th phosphorus electron, which is assumed to be a 3d orbital, overlap with the another unpaired electron in p orbital of p orbital of oxygen to make d pi p pi bond. This bonding of is supported by multiple bond character of the phosphorus oxygen bond of the acid anion. So these 3 structures are monobasic, dibasic, tribasic. This shows that structure of these acids is such that phosphorus atom is tetrahedrally surrounded by neighboring atoms. The hydrogen atom directly linked to the phosphorus atom are responsible for the reducing properties of oxyacids. And so these are the 3 structures of these oxyacids of phosphorus. And next is the structure of HPO3, the fourth one, and HPO3 is a monobasic acid, and its structure is shown here of this HPO3. So here HPO3, and only one replaceable hydrogen is there, and because one OH group is there, so this is monomer. It can get dimer. So here this is the dimer, 2 molecules get joined, and HPO3. See here, if you see, this is one and this is another one. This is one and this is second one. Two molecules joined, and this is dimer. This is another trimer, HPO3. This is one, this is second, this is third. So this is trimer. In the same way, the HPO3 can join n number of times and forming a polymer. So this is the monobasic acid having replaceable one hydrogen atom. So in this way, if you take the HPO3 n times, forming a long chain of polymer. So this is the structure for HPO3. Another structure is there, structure of these two H4P2O6 and known as hypophosphoric acid, and next is the pyrophosphoric acid. Both are tetrabasic, and now here tetrabasic means there are replaceable 4 hydrogens are there. So this is the structure 1, 2, 3, 4. 4 OH groups are there, and therefore there are replaceable 4 hydrogen atoms. And the structures of this is shown pyrophosphoric acid H4P2O7, and this having POP bonding is there. POP bonding is there, and this indicate this is the it is a tetrabasic, and first one is a hypophosphoric acid, and second is pyrophosphoric. This is a hypophosphoric acid, this is pyrophosphoric acid. Here is one oxygen less, and therefore there is a PP bond, but here one more oxygen is here, therefore having POP bond type of linkage is there. So formula of this compound is H4P2O6, H4P2O7. So one more oxygen is here, so between the two phosphorus there is a oxygen linkage. In this way the structure, and both are the tetrabasic because contain 4 OH groups. Now next part we are going to see, that is the oxyacids of sulphur, and as we know, sulphur forms large number of oxyacids either in free state or in the form of salt or both. Oxyacids contain sulfur-sulfur link are known as the thioacids, and oxyacids having sulfur in lower oxidation state belong to OUS series, while those having sulfur in higher oxidation state belong to IC series. So two types of compounds are there, OUS AD and IC 2 series are there. And based on this, now lower and higher oxidation state. So here these are the table. This table shows the sulphurous acid series. So sulphurous acid, thiosulphurous acid, hyposulphurous acid, pyrosulphurous acid. So here OUS is the end, and here oxidation state is shown +4, +3, +3, +1, +3, +4, and these are the formula of this series of sulphurous acid. Another type is the sulphuric acid. Last is the IC. So here +6 is the higher oxidation state, and so lower oxidation state end with the OUS, higher with the IC, and formula of these compounds are shown here. Thionic acids are also there, dithionic acid, polythionic acid, and oxidation state is +5, and here maybe 3, 4, 5, 6 are, and these are the formula. And important compound here is a peroxy acid series. Two important compounds are there. One is a peroxy monosulfuric acid, and this compound is also known as Caros acid, and second is a peroxy disulfuric acid, also known as Marshal acid. And we are going to see the preparation of these Caros acid and Marshal acid and their structures, and this is the important part in this case. So this is the table which shows different oxyacids of sulfur. And now first compound is the peroxy acids of sulfur. First number is the per-disulfuric acid, which is known as Marshal acid, and in this case the formula is H2H2O8. So this is the formula of per-disulfuric acid, also known as Marshal acid, and it can be prepared by the two methods. One is by anodic oxidation method, and in this method shown here, this is the ice bath, and we have to take the sulfuric acid 50 to 60% in this tube, and now then this spiral copper wire is there. This is act as anode, and this is the another tube here which is a cathode, and after making all this arrangement here the reactions are taking place. So in this case the ionization are taking place. Sulfuric acid we have taken 50 to 60%, so it get ionized forming H plus and HSO4 minus. Water get ionized H plus OH minus, and at anode the reaction taking place. These two OH forming 2 OH here minus, and 2 electrons are liberated, and here 2 OH now forming H2 and O, and this react with the HSO4 minus. Here 2 HSO4 minus with H2 and O forming 2 HSO4 and 2 OH minus. So this is the oxidation, and this 2 HSO4 is nothing but we can write H2H2OH. This is the per-disulfuric acid. So at the anode we get this Marshal acid, and in this way this H2SO, this compound can be prepared. So in this arrangement of the figure is shown, we have to take 50-60% concentrated sulfuric acid in a big test tube. A cylinder around which platinum or wire is there is placed in the test tube. Platinum wire acts as a cathode, and a fine wire of platinum in the form of capillary is suspended to act as a anode. The test tube is placed in a freezing mixture as shown in the figure. A current of 1 to 2 ampere each pass, and in the cylinder around anode per disulfuric is formed. So in this way at anode we get this Marshal acid or per disulfuric acid. So this is the arrangement for the synthesis or for the preparation of this per Marshal acid by using the anodic oxidation. Therefore at anode we get this product, therefore it is known as anodic oxidation. Another method of preparation of Marshal acid is here as per the definition of the molecular weight gives the empirical formula of acid is HSO4, and the molecular weight is gives molecular formula H2H2O8. So now as per the definition of per acids, the acid or its salt react with the dilute sulfuric acid to give hydrogen peroxide. This indicate this is the structure of this compound, and in this case structure shows that first compound different points are there. So 4 different points are there. First, structure of Marshal acid. Empirical formula of acid is HSO4. Molecular weight gives molecular formula H2H2O8. As per the definition of per acid, this acid in its salt react with the dilute sulfuric acid to form hydrogen peroxide. This indicates the presence of peroxide linkage. It is also prepared by the action of chlorosulfuric acid with the hydrogen peroxide, and this is also another method of preparation of this Marshal acid. So this is the chlorosulfuric acid, hydrogen peroxide, and the reaction shows here HCl and form HCl. Chlorosulfuric acid, hydrogen peroxide, chlorosulfuric. We have to take the 2 moles of chlorosulfuric acid and 2 moles, 1 mole of hydrogen peroxide. So hydrogen peroxide and Cl from this, H from this and Cl, 2 HCl get replaced, and we get this type of H2H2O8 per disulfuric acid. This is another method of preparation of this Marshal acid, and this is the structure of this compound. So 2 tetrahedron, this is the 1 tetrahedron, this is another tetrahedron can join together and forming this type of structure for this Marshal acid. And now second compound is the Permono sulphuric acid, which is also known as Caros acid. Formula is H2SO5. So first method of the preparation of this compound is from potassium persulfate. In this case for potassium preparation, the concentrated sulphuric acid is added to the potassium persulfate at low temperature. The mixture is allowed to stand for 1 hour, and then pour this over crush ice. When we get the Caros acid. So this is the method. So this is the per disulfuric acid. Sulfuric acid added. What is then we get H2H2O8 and K2SO4. So here H2 is coming here, K2 comes here. So H2H2O8 and K2SO4 another product. So we also take this per disulfuric acid and also water and forming H2SO5 and H2SO4. This is the Caros acid, and so this compound we have taken here, and again now what else we get the Caros acid. So this is the Caros acid H2SO5. Formula is H2SO5. Another method is by using chlorosulfuric acid. Caros acid can also be prepared. So this is chlorosulfuric acid and hydrogen peroxide reacting forming H2SO5 and HCl get released. H and Cl from this. And another method from sulfur trioxide, and it also react with the oxide to give the pure Permono sulfuric acid. And this is the SO3 H2O2 react forming H2SO5. So these 3 methods of preparations of Permono sulfuric acid, also known as Caros acid, are there. And after that we are going to see the structure of this Caros acid. Again now here the molecular formula of this compound is H2SO5, and on reaction with dilute sulfuric acid it gives hydrogen peroxide, which indicate the presence of peroxy linkage, and equimolecular mixture of chlorosulfuric acid and hydrogen peroxide react give the Permono sulfuric acid, and the reaction shown here. This is the hydrogen peroxide and 2 molecules of chlorosulfuric acid, H from C, this replace and forming this type of H2SO5 compound. 1 mole of this, 1 mole of this, 1 mole, and we get this type of compound, and HCl get replaced. And this is the structure, tetrahedral structure having peroxide linkage. So sulfur in this compound is a sp3 hybridized and give tetrahedral structure of this compound, and out of 4 oxygen atom, at the corner one of the oxygen atom is linked to the 5th oxygen atom by covalent bond, and therefore the structure of acid can be written shown in this slide. So this is the structure for Permono sulfuric acid, which is also known as Caros acid, and formalized H2SO5. So this is the structure for this compound, and this is the structure of Caros acid. So today we have discussed about the oxyacids of phosphorus and oxyacids of sulphur, and also we have seen different structures, and especially we have seen the preparation and structures of Marshal acid and Caros acid, that is the peroxy acids of sulphur.